Hello, my name is Gabe. For this problem, we're given the equation of a hyperbola, and we're asked to find the center, the foci, the vertices, and then sketch the graph of the hyperbola. So, before we begin, we'll really want to try to rewrite this equation so that it's in standard form. And the way that I'm going to start doing that is by grouping these x terms and the y terms together. So rewriting this equation, we'll have x squared plus 2x. We'll group these together using parentheses. And let me leave maybe just a little bit of space here. And let's group these y terms together. So we'll have, let's first note that we're subtracting a 9y squared, and we're subtracting a 54y. So let's minus, and then we can put everything else inside the parentheses. So we're subtracting a 9y squared. So in the parentheses, we'll have a 9y squared. And we're also subtracting a 54y. So since we put this minus sign out in front of the parentheses, this will become a plus 54y. And now I'm going to take this minus 85 from the left side, and I'm going to move it to the right-hand side by adding 85 to both sides of the equation. So now we're getting a little closer to standard form. So something we're going to want to do is we want to complete the square both here and here. And at this stage, we can't complete the square on this 9y squared plus 54y because this leading coefficient of the y isn't 1. But we can do it here, so let's go ahead and do that. So we see that b here is 2, halve it, we get 1, square it, we get 1. So we're going to add 1 right here to complete the square. Now since we added 1 to the left side of the equation, we'll want to add 1 to the right side of the equation also. So what we have is this factors into x plus 1 quantity squared. Now here, since this y squared coefficient isn't a 1, we'll have to factor out a 9 in order to make that a 1. So what we'll do is we'll factor out a 9 from both 9y squared and 54y. And what we're left with is 9 times y squared plus 6y. And I'm going to leave a little bit of space here because we're going to come back and complete the square. And this is equal to 86. So here we see that b is 6. If we have 6, we get 3. And then if we square it, we get 9. So we're going to be adding a 9 here. Now, we'll want to be careful because we really did not just add a 9 to this left side of the equation. We actually added a 9 times 9, but since we're actually subtracting this whole piece here, we actually subtracted 81 from this side of the equation. So since we subtracted 81 from this side of the equation, we'll want to subtract 81 from the left side of the equation. So what we're left with is the quantity x plus 1 squared minus 9. This right here becomes y plus 3 quantity squared. And this is equal to 5. So the next thing we're going to want to do is divide each side of the equation by 5 so that we have a 1 on the right side of the equation. So dividing everything by 5, we'll have x plus 1 quantity squared divided by 5 minus 9 times y plus 3 quantity squared divided by 5 is equal to 1. So from here, we'll want to take this one step further in order to get this in standard form. And the way we're going to do that is we're going to rewrite this 9 divided by 5 as 1 divided by 5 ninths. So let me show you what I mean by that. So this expression is actually equal to x plus 1 quantity squared divided by 5 minus y plus 3 quantity squared divided by 5 ninths, which is equal to 1. So now we can go ahead and we can grab some information from this equation. So what we see here is that this is the standard form of a hyperbola, which opens horizontally. We see that we have our a squared value is 5. So that tells me that a is equal to the square root of 5, which, for our purposes, is approximately equal to 2.24. We have b, or b squared is equal to 5/9. So b is equal to the square root of 5/9, which is going to be approximately 0.75. So we have our a values and we have our b values. We can also grab the center from here. So we can grab the fact that h in this case is equal to -1 and k is equal to -3. And again, the reason why we think about it like that is because we want to think about this x plus 1 as an x minus -1, and we want to think about this y plus 3 as a y minus a -3. The last thing we'll want to do is find our c value. So we know that c squared is equal to a squared plus b squared. So we know what a squared is, and we know what b squared is. So we'll have c squared is equal to 5 plus 5/9, which is going to be 45/9 plus 5/9, so 50/9. Now we can solve for c by taking square roots. And we get that c is equal to the square root of 50/9, which for our purposes, we can say is equal to the square root of 50 divided by 3, which is approximately 2.36. Now, let's see if we can use this information to go ahead and find the center, the foci, and the vertices. So first of all, we know that the center is given by hk. So the center is this point hk, and we know that h is equal to -1 and k is equal to -3. So the center is going to be the point -1, -3. So let's go ahead and let's plot this point. So thinking about -1, -3, that will put us right about here. So this is the center of our hyperbola. For the foci, well, we know, judging by the standard form of this equation, that our hyperbola is going to open horizontally. So what we're going to be looking at is we're going to be looking at the points h plus or minus c, k. So what this is going to leave us with is 2 points. First, we're going to have -1 plus our c value, the square root of 50 divided by 3. And k is still -3. And our second focus is going to be -1 minus the square root of 50 divided by 3. And the y-coordinate is still -3. So we can go ahead and we can plot these. So we'll want to think about starting at -1, -3, so starting at the center, and we'll want to move to the right and to the left this square root of 50 divided by 3, which we found to be approximately 2.36. So imagine moving 2.36 to the left and 2.36 to the right. So these 2 points are our approximate foci. So the next thing we want to do is we want to find our vertices. So since our hyperbola opens horizontally, our vertices are going to be given by h plus or minus a k. So this is going to give us 2 vertices. The first is going to be our h value, which is -1, plus our a value, which is square root of 5, and our k value remains the same, -3. And our second vertex is going to be h, which was -1, minus a, which is the square root of 5, and our k value is -3 still. So now we have our vertices. So we want to imagine starting at the center and moving to the left and the right, the square root of 5 value, which we know is approximately 2.24. So imagine starting at our center, moving to the left, 2.24, and moving to the right, 2.24. So now we have our center, we have our 2 vertices in blue, and we have our foci in green. So what we want to do is we want to try to sketch the graph, and we'll want to use these asymptotes as an aid. So in order to do that, we'll want to actually go back and we'll want to look at our b value. So b in this case was 0.75. So what we want to imagine doing is starting at the center of our hyperbola and moving up 0.75 and moving down 0.75. So now, for these 4 blue points, we want to imagine drawing a rectangle through those points. And what we can do from here is we can think about, well, connecting the 2 opposite corners using a straight line. So I'm going to go ahead and draw a dashed line through these opposite corners. And these right here are asymptotes. So finally, all that we have to do is sketch the graph of our hyperbola. So as we mentioned before, we want to be careful in noting that our hyperbola opens horizontally. So we don't want to come down and come up and then come up and back down. We'll want to open to the left and to the right. And we'll want to make sure that we don't cross our asymptotes and that we pass through our vertices. So there's the graph of the hyperbola. Thank you.